In this lesson, we revisited long division and the reverse tabular method by looking at these quotients where we had remainders that weren't zero, where we had remainders that were not zero, which means we did not have factors, but we can still do division. So the first problem I ask you to do x to the third plus 7x squared plus 14x plus 3 divided by x plus 2. I'll start by doing long division here. I will switch between both methods through this entire video. But if you're good at one, use it and stick with it. So, long division, it's the same thing, except the end result's going to be a little bit different. We have x squared times x is x cubed. X squared times 2 is 2x squared. Change my signs to subtract. I get 5x squared plus 14x plus 3. And we start over. Well, 5x times x is 5x squared. 5x times 2 is 10x. Change my signs to subtract. And I'm left with 4x plus 3. And we start over again. Well, 4 times x is 4x. 4 times 2 is 8. Change my signs to subtract. And we have a remainder of negative 5. So this quotient equals x squared plus 5x plus 4 plus negative 5 over, well, what did I divide by? I divided by x plus 2. So you can put that negative 5 up top, or you can move that negative out in front of the fraction and say minus 5 over x plus 2. But that's all we do when we have remainders that are not 0, is we take our quotient plus remainder over divisor. Remainder over whatever we divided by. This tells us x plus 2 is not a factor. It's not a factor of that x cubed plus 7x squared plus 14x plus 3. Let's do reverse tabular method for this next one. 2x squared minus 13x minus 10 over 2x plus 3. So I'm dividing by 2x plus 3. I'm going to make my table. I need 2x squared from that term, negative 13x there, and then minus 10. Okay, that 2x squared goes in up there, and I say, well, x times 2x is 2x squared. Multiply, and I get 3x there. I want negative 13x. I've got 3 of them. I need to get all the way down to negative 13. Well, negative 16x plus 3x gives me negative 13x. Well, negative 8 times 2x is negative 16x. Multiply through, and I get negative 24. But I only want negative 10. So what do I need to stick on there to get me to negative 10? Negative 24 plus my remainder needs to give me negative 10. So my remainder, add 24 over, is 14. So this final answer, when you divide those two, you get x minus 8 plus 14 over 2x plus 3. So finding the remainder is a little bit trickier in reverse tabular because you say negative 24 plus my remainder has to give me negative 10. So at least with long division, that's why I like long division a little bit better, is because it explicitly tells you what the remainder is. You have to do a little bit of thinking and work over when you do reverse tabular. But it still works. If you're good at it, excellent. This third one here, I'm actually going to use inspection for. I'm actually going to use inspection for this one. Inspection. You could do long division, you could do the reverse tabular, and I'll show you how you can use long division. But inspection is actually the easiest thing to do here, because you can say, wait a minute, I'm dividing by x plus 1. I think we can all agree that that numerator, look what I did there. I just have x plus 1 minus 3. If you combine those like terms, what happens? It becomes x minus 2 again. So I just changed the way it looked. Now, I'm going to divide by x plus 1, those guys and that guy, so x plus 1 over x plus 1, minus 3 over x plus 1. Well, x plus 1 divided by x plus 1 is 1, minus 3 over x plus 1. Inspection is great for if you recognize the structure and see how you can tear it apart to simplify these expressions. If you did long division, I'm dividing by x plus 1, x minus 2 goes on the other side. So 1 times x plus 1, change my signs to subtract, I'm left with negative 3, which is exactly what I've got over here. So either method works. Reverse tabular would just look funny, but you could do the reverse tabular method. But inspection is kind of what I wanted you to try there. And finally, this last one, flip a coin. What am I doing? I'm doing long division. Sorry, reverse tabular people out there. I've got 9x cubed minus 12x squared. I can't put a plus 4 there because I need a placeholder. I'm missing my 0x term. Make sure even if you did reverse tabular that you accounted for that 0x term, otherwise things won't line up nicely. Well, 9x squared times x is 9x cubed minus 18x squared. Change my signs to subtract. That goes to 0. I'm left with 6x squared plus 0x plus 4. And we start over. Well, 6x times x is 6x squared minus 12x. That's why I need that placeholder there. Change my signs to subtract. 12x plus 4. And we're almost there. We just do it one more time. 12 times x is 12x. 12 times negative 2 is negative 24. Change my signs to subtract. And I'm left with a remainder of 28. So my quotient is 9x squared plus 6x plus 12. That's my quotient, plus 28's my remainder over x minus 2. That's my final answer there. That expression is equivalent to the one that we started with. So really the only new piece in this lesson is how do we deal with remainders that aren't 0? And the key thing is, if you have a remainder that's not 0, it's not a factor. And we really care about factors, because that tells us where the zeros are on the graph. We end with number 2 here. Let p of x equal x cubed plus 2x squared plus 2x minus 5. Divide p by x minus 1. I will do reverse tabular because I just did long division. I'm dividing by x minus 1 here. Got x cubed, 2x squared, 2x. I still need one more, negative 5. Okay. X cubed goes in that box. Well, x squared times x is x cubed. Multiply down, that becomes a negative x squared. I want 2 of them. I've got negative 1, so it looks like I need 3 more. Plus 3x minus 3x. I want 2. I've got negative 3. So it looks like I need 5 of them. Well, 5 times negative 1 is negative 5, so I don't have a remainder. So when I divide p by negative 1, I get x squared plus 3x plus 5. My remainder is 0 in this case. Then find p of 1. Well, p of 1 means plug in a 1. 1 cubed plus 2 times 1 squared plus 2 times 1 minus 5. 1 plus 1 squared is 1. 2 plus 2 minus 5. Well, 5 minus 5 is 0. So p of 1 equals 0, which, wait a minute, my remainder is 0, and p of 1 gave me 0. Interesting. So I noticed that p of 1 was equal to the remainder. Because it was 0, x minus 1 is a factor of p.